So rational coefficients. So to get rid of denominators, all right, I'm just going to erase this for a second again. So find your common denominator, all right? So the goal is to eliminate the denominator, all right? So when you multiply, let's look at it, maybe I'll look at it this way. So my common denominator is 6,
Yeah.
all right? But a 3 and a 2,
Yeah.
all right? So let's say that I multiply this one by the 3 and the 2, this one by the 3 and the 2, this one by the 3 and the 2, rather than a 6, right? Because 3 times 2 is 6. So give me a moment, right? Do we agree that's 6? It's just in factored form, 3 times 2. But what happens when I have a 3 in the numerator and a 3 in the denominator?
That is wonderful.
They cancel out. So they're going to cancel out. So in reality, what is this thing? Well, 2 times 2 is 4x. So you got to remember, the purpose of that common denominator is to cancel a denominator. So here I multiplied by the 6 again, which is 3 times 2. But do we notice that there's a 2 in the numerator, a 2 in the denominator? Okay, and then we end up with 3 times 5, positive 15y.
And then equals 168.
Now, y, can I not, is there anything to cancel in the denominator? No, there wasn't a denominator there in the first place. So 28 gets multiplied by the 3 and by the 2, which becomes out what? 168. Okay? Now you'll notice these sections, the numbers will be a bit larger. All right? So now I've got it back to where I had it in the last section. All right, so now let's go over to here. My common denominator is 8, right? It's like so I'm going to break it up.
A 4 and a 2.
4 and a 2.
Cancel out.
Okay, this one I'm going to leave as an 8 because I don't need to break it up into a 4 or 2. And this one, I need another 8 too. So why did I break this one up to a 4 and a 2? So I could cancel my 4s.
Hi, can I borrow Rebecca?
Can she come in about 10 minutes? 10, 15 minutes? I'm teaching right now.
Actually, I got a doctor's appointment, so I'm gonna have to leave at like 1:30.
Okay. Yeah, do you want to go instead? Yeah.
Sorry.
All right, so I'm canceling out the 4s. That leaves me with the 2 and the 3 giving me a 6x. These both cancel out,
Negative 1. Why? Equals a 64.
and then I get a 64.
A negative.
Does that help a little bit more?
Yes, ma'am.
Yeah? Anybody still confused?
No.
So the purpose of those common denominators is to eliminate the denominator. Okay? However, this is pretty much this whole section. All right, so now that I have these two, I'm going to put the box around them because now I can work with these, just like I did last day. Okay?
Yes.
Now your choice after that is to choose between substitution or elimination.
Elimination.
Okay? I'm going to do, I know everybody likes to do elimination. I'm going to do substitution on this one just because it does have a y in there. And no, just so that you remember both of them. All right? So I'm going to do substitution on this. Could you have done
Could I just do it?
Thursday?
Thursday.
Substitution makes
Could I
more
just
sense.
do it?
Yes, it does.
Could I just do it elimination of every single question?
You could unless I ask you for substitution, which I'm going to ask you on the test to do substitution. So you have to be able to do that. All right, so I'm going to use substitution because we still need to be able to do it. All right, so I'm going to use this one. I'm going to isolate my y here by going negative 1y is equal to a negative 6x plus 64, and then going 6x minus 64. And then I always like to underline them, right?
Yes, ma'am.
So I've taken this one, I now am going to go back over to the other one. 4x plus 15y equals 168, and put this in for the y. And again, you'll notice they're going to be larger numbers in this one just because. 15, take out the y, 6x minus 64. Okay. So I'm going to get
And 90x.
I can do it. 4x plus 90x minus 15 times 64 gives me a negative 960. 168.
That's a big number.
Yep. All right, Cruz. So I get a 13x equaling 168 plus the 960.
One.
So I'm going to add the 960 to this side.
Before.
Oh, 15 times 64.
Yeah.
Oh, I forgot 90. There we go.
That's equal to
Thank you. There we go. I'll fix that. 94x. There we go. Now I'm good, right? 1128 divided by 94 gives me a 12. There we go. So I did that. I took 2, substituted into 1. Now I'm going to go back the other direction to make the full circle. Again, I'm going to go to the one that's in the box. 6x minus 1y equals 64. So 6 times 12. What is that? 72 minus 1y equals 64. Y equals 64 minus 72
-8.
gives me negative 8.
And then you get a y of 8.
Perfect. Then write your solution set. 12 and 8.
Please, man.
Okay? So that's substitution. Remember that?
Yeah.
And again, you could have solved it with elimination, but if I ask you to do substitution, you should be able to do that. Okay?
That actually wasn't that bad. I honestly.
What do you mean?
Like, fractions, is that it?
No, I have 2 other examples. Okay? So now, I'm going to go do the second example one, and then I'll come back to the third kind. So this one right here, you'll notice that nope, I'm going to do one without fractions here. This one had no brackets in it whatsoever, right? This one, let's do some bracket ones. All right, so I've got a 2 bracket y minus x plus 2x plus 3y equal to an 80. That's equation number 1. And equation number 2 is a 5, 2x plus y equal to a 7, x minus y plus 90. It is very long. But it's not something that can't be done. Okay, so question number 1 had fractions, question number 2 has brackets. Ladies? No, there's no fractions. And then example number 3 will be a combination of brackets and fractions. So this one, distribute through your brackets. 2y minus 2x plus 6x plus 9y equal to 80. So we get a 4x plus an 11y equal to an 80. You can do the next one.
The next one.
It's the same thing, except you'll have to move some terms too. All math is relatively the same, except for it's a little different. Otherwise, you're just doing the same question over and over again, which doesn't get us very far.
I'm gonna want to go show us how to
She's got 15 minutes if you need to see her. (10x) plus 5y equals 7x minus 7y plus 90. 10x minus 7x plus 5y
Minus 3.
plus 7y equals 90.
What's your language there, Miss
I literally said what the.
You know.
So, some of, why? Just because I moved it down so I could put it in a box. I should have moved it down right away, but I didn't, and I thought why erase it? It'll be faster just to write it twice.
You shouldn't do things fast.
Well, did we write this step out? Did we actually put this over? Because otherwise our brain doesn't always think. And then we end up with like a 3x and a -2y. Because we don't switch the signs.
I almost did that,
Yes, write it down.
but I did.
All right. Now, I would use elimination for this one because of the fact I don't have an x and a y to isolate, right? So I'm going to take this one and times it by 3 and this one by 4. I want to get my x's the same, so I don't have such large numbers.
You could eliminate your x in your second one, dividing everything by 3.
Oh, you want to, yes, you could put it back to an x, yes. If you want to divide everything by 3, because this one is 3 times bigger. Yes, you could do that too. And then times it by just, it's a multiple of 3. So he was thinking, why not reduce it before you multiply?
I was actually thinking.
Or you're going to use
with
substitution?
Substitution.
Yeah, you could do that too.
Eliminate your x.
So you reduce this by 3, got it to be a 1x plus 4y equals, right? I'm going to now make my x's the same, so I can do elimination. Okay? Your choice. So this top one here will become 12x plus 33y equaling a 240. Then I'm going to make the other guy a 12x plus a 48y and a 360. If I was smart, I would have put the second one on top, but that's okay. We'll work with negatives. Now we subtract, right? It's 12x minus 12x. I want to eliminate my x's. So 48 subtract 33 gives me, you know, I'm just going the other direction, so I don't have to think some minuses, negative 15y. And 1, 2, 0, and it's negative.
I can't see what you wrote.
Right there. See, it's right there. And 15 goes into 120 8 times. Technically, you're supposed to go back to an original to substitute, but I'm just going to put it back into one of the squares and hope for the best. Since I got a nice number, I'm assuming that these two are correct, and I don't have to go back to all the way to an original. Okay? Yes, I know. Not very fun. However, technically, mathematically, you're supposed to go back to the original, which would be the bracket one. All right. I'm going to pick, just because it's there, I'm going to pick this one, right? 3x plus 12y is equal to 90. In my 8, multiply that, what do I get? 96. My 12 times table is. I know, my 12 times table is horrible, though. 6 and x is negative 2. And last question of Foundations 20.
So let me do no more questions after this?
One more.
Yeah, we can walk out.
One more. No.
You said it was the second last question.
Second last question of the examples. And then I'm done teaching.
You didn't specify that, so technically.
Tie.
False advertising.
Tie.
Girl. I know what you're.
False advertising.
That's all recorded on video.
It's all recorded, yeah.
Yeah.
So we all should.
All right, we did a substitution, we did an elimination. Now I'm gonna stick the two questions together.
Actually, technically, it has more questions on one. So when you said there's only so many questions, that's correct.
No, there's only so many combinations, patterns, right? It's the same pattern over and over again, you're just changing the numbers. All right, let's put the two things together. All right, we ready? Emma, you good? I can give you this after, Rebecca. Okay, here's the combination. Last question. Let's even write it out. Last example.
Again. Oh, they're not just numbers.
Foundations 20. There we go. All right, here's number 3. You have an x minus y over 4. Plus a 2x plus y over 5 equals 8. And a 1/2 x plus 2y plus 3 over 7 x minus 4y equal to 14. Oh, it's not quite the last example. I'm just going to show you.
False advertising.
I'm just going to show you decimals, but I'm not going to solve it. So the last solvable question of Foundations 20. Because there's decimals, but I'm not going to solve one. I'm just going to show you what to do.
It's like holding
No.
in front of somebody's face and
How about you do the assignment on your own, but I'm going to show you this one. So again, we have a combination of brackets with fractions. So again, fractions are the thing that we need to eliminate first. Oh, sorry, equals 14. There we go.
Yeah.
All right, so again, we're looking at our common denominator. And again, use your common denominator as the two numbers, right? So I'm going to put a bracket around my binomials in my numerator. There's my brackets, all right? They technically have ones in front. Yes. Yes, we're going to do that in a moment. However, 20 is my common denominator. I'm going to leave it as a 4 times a 5. 4 times a 5. And this one, I'm going to just use a 20 because I don't have any denominators to eliminate. Okay, it's going to be the exact same thing as I did in question number 1. Why am I doing that 4 times 5?
So then you cancel out.
Because then I can just cancel the 4s out. Now, what is the actual number that's in front of that bracket? 5. 1 times the 5, giving me a 5. Don't distribute through yet. Okay? No, well, if it's a subtraction, the odds of you distributing a negative through changes, and then you end up with one term that's the wrong term, and then all hell breaks loose, and then we get answers that don't make any sense. So stop. Don't do more than you should. All right, again, I left it as a 4 times a 5 so that I could cancel my 5s out. And 1 times 4 is 4. And then, good. Does that make sense? Does that clear it up?
Can we distribute now?
Yes.
Okay, I did that.
I'm going to distribute now. And I'm going to clean up my terms. What do I got? 13x. I have time. I'll erase.
Do we have to write out the very first step of that?
Ty,
Or can we just skip right
Shut
to
up,
the second?
Ty.
what kind of mistakes do you make, Ty? What kind of mistakes do you make?
In this one, I made 0 mistakes.
Yes, but is that 100% of the time? 100% of the time you're not going to make a mistake?
No.
Then I would write it out.
Nothing in life is 100%.
Write it out.
Ty, the only thing that's 100%.
Right, Emma. All right, again,
That's 100% life is that.
I'll give you a moment to try this one out. Don't dawdle there, Corey Joe. I'm giving you a moment. I'm giving you a moment to try it. All right, keep going then. Give it a try.
It's literally the only one actually doing the work.
Don't dial. What's wrong with this one?
No, we're just talking about.
Actually, I have one more thought.
Be nice.
So we're just outing them on camera.
Be nice.
What did she say?
Nothing.
Well, that's recorded, Tony.
What did she say?
Oh, you're gonna get dropped. Don't watch the video.
There.
14.
Am I multiplying this one by 14? No, I'm not. I'm gonna multiply it by a 7 and a 2. This one by a 7, 2. But this one I can multiply by
2.
a 14, because it only has a denominator of 1. I'm not gonna be canceling anything with that one. So I can just multiply it together.
I genuinely cannot believe I'm going to train
Okay, I don't know if I did the second one right.
So I'm gonna cancel.
You do the fractions first?
I always do my denominator first.
Why?
Why else would you?
Well, are the brackets come first?
Nope, denominators do.
Can you distribute?
Where have you been?
makes 0 sense.
Don't brackets always come first?
Not in, when you have a denominator and solving equations. Nope, get rid of your denominators first.
Can you?
Because if you distribute first, you're actually creating 4 fractions on this side.
No.
So you
No,
can't
just
do
simply.
3x minus 12y over 7?
3x over 7 minus, like he wants to distribute the fraction into the bracket first.
Like, can you distribute the 3 into the bracket first?
That's what I did.
With the 7,
And then you
but you'd have to take the 7 with it. It's 3 7s into x. 3 7s times by a negative 4y. It is not just 3 into x, 3 into that. It is the whole fraction gets distributed in. Don't do that, because then you're creating 4 fractions, right? This first one works out nicely, because, well, the 2's will cancel, but, yeah, no, you're just creating 4 fractions, which then you still have to get rid of a denominator, right? And that's the key thing also, is if you keep it inside the bracket, it's still one term. By distributing it in, you're creating 4 terms, not just the terms that are there. Okay, 7, what's left over? The 7 and the 1, right? 7. X plus 2y. Again, I'm writing this step out because it has a greater chance of me not making a mistake. It works mathematically, but it's a lot more work.
You kind of proved it. It worked.
Yeah, mathematically it does work. 13 and 14 is what?
196.
196. Okay? Distribute 7x plus 14y plus 6x minus 24. I didn't say it didn't work.
So how is it so much more work though? Same amount of work as that.
It's the same amount of
That's all it is, nigga.
Are you, it depends where you put your denominator,
phone.
okay?
Just all it is, nigga.
Depends where you put your. I did it. I hit submit.
She has that one math teacher friend that actually watches her.
I'll do it again.
So,
Yeah. I hit submit.
Just all it is, nigga.
I have it already submitted. Positive I did. Let me look. What expired on me? Now I have to log back in.
I do that for whatever. That's how I watch this recording.
The phone is ringing.
Pick up the phone.
There you go.
Why? I just didn't pause it.
All right. Yeah.
what do we do next?
All right. So we distributed, right? So I got rid of my denominator, distribute, collect your like terms. I'll get a 13x, what is that, minus 10y equals 196.
Yup.
And again, you could do substitution with this one, or you could do elimination with this one. Your choice.
Why didn't you know?
It's so much easier. Oh my god. It makes really large numbers.
Substitution does give you large numbers.
If I did it right, I have 130 and 1600.
Do it.
Yeah, it could give you large numbers,
Understand how
yeah.
that royally messed that.
Yeah, 1,600, 117. I have 117 in there somewhere.
I'm going.
Oh,
Oh,
yep.
yeah. That could be.
Let's see, shall we do substitution or elimination?
Substitution. Substitution.
Oh, we have elimination, look at this, 13 X's.
Yeah, but you
Why?
substitution.
I'm gonna do elimination, because what is the odds that I have 13 X's in both of them? I'm gonna put this guy on top, though.
I think substitution.
13X minus 10Y equals 196, and 13X minus 1Y equal to 160. And I'm gonna subtract. What are the odds of you getting like 13 X's? I'm going to add the 1 to get a negative 9Y. And I'm going to subtract that off, giving me a 36. Y is negative 4. Doesn't make a difference, either of them. I'm going to go this direction. 13x minus 1y equal to 160. 13,
I missed something.
what'd you miss? I just stacked them on top of each other. You could have put this one on top and that one on the bottom. Doesn't matter.
Negative 10y to, oh,
Add 1.
yeah.
Yeah. And negative 1 times negative 4. 13x plus 4 equals 160.
Is there a way to go backwards?
In what way? What are you talking about?
X equals. Or X equals 12 and you go backwards.
Like factoring.
Which you need.
And then you go backwards and make
Like,
this entire
if you
equation.
got, like,
Or are you wanting to make one?
like you have a solution set, but you want to make an equation. Can you do that?
Yeah.
You could,
Go back
yeah.
to those.
Yeah.
Find those.
Yeah, you could make one.
All you have is that.
Yeah.
What if you only have X
Is there,
equal to
is there
12?
high school math that teaches that? Like, you do that.
AP foundation.
Problem is there's an infinite amount of solution or questions, right? This is one specific question giving you one specific answer. You taking an answer going backwards. Like if I asked you, give me a question that gives me an answer of 5, right? Somebody could go 8 minus 3, the other one could go, 4 plus 1, right? There's an infinite amount of questions to make an answer of that,
Okay,
right?
I got it.
Whereas, think about what this is. This is one point on an X and Y grid. There's an infinite amount of lines that could go in any direction, but they're just meeting at that point, right? All right, that was the last one. I'm just gonna put number 4. But I'm not gonna solve it because it's just, you do need, it's just number 9. It's number 9 in your questions. 0.3x plus 0.25y equal to 1.
Whoa, man, we're going with the 3 right now.
Yes, I'm going to show you the first step, but you have to solve it in your question. I'm not solving it. I'm not solving it. Don't give me that, little girl. Well, then do what to do. It's part of the questions in your assignment. I'm just helping you out with the first step.
I don't want to do this.
Okay? So, decimals. I don't want to have to work with decimals.
Okay.
All right? So if you're going to, if you have a decimal question,
Times 10 to the power of negative 1.
no, I don't want powers of negative 1. No, I don't want fractions.
Actually, get rid of the common denominator.
I don't want fractions. How do I, scientific notation, the easiest way is just times it by largest place value.
100.
Right. So in this one, my largest place value is this guy. Take this guy, times it by 100.
Hit that D1.
So you get a 30x plus 25y equal to 100. However, this one, do I need to times it by 100?
No.
What can I multiply it by? Exactly. 7x minus 4y equal to 102.
We can just finish this off.
And this is question number 9 on your assignment, so you can answer your own question. Okay, done.
Wait, okay, I have a question though.
Cool.
Question, yeah.
What?
If you wanted to, could you put them into fractions, find a common denominator?
Yes,
See, I wasn't wrong.
that creates quite a nightmare of things, but if you want the challenge of it, go ahead.
So we literally just wanted to get them into a form we could actually work with.
Yeah, it's much easier to work with whole numbers than to work and integers than it is to work with decimals, right? Decimals, then we're using a calculator all the time. Right, that's it.
So I finished.